Okay, so the question is longest consecutive sequence. Given an unsorted array of integer nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs on O of n time. So given an input array 100, 4, 200, 1, 3 and 2, we need to return the length of the longest consecutive sequence. So here the longest consecutive sequence is 1, 2, 3 and 4. So the length is 4. That's what the output says. The easiest way to do this is to sort this array. So after sorting, the array will be looking something like this. So we have 1, 2, 3 and 4 as the consecutive sequences. 100 and 200 are separate numbers. So the length of the consecutive sequence is 4. So this is the code for the brute force solution. What we are doing is sorting the array. Then we are initializing a count variable. So after that, we are traversing into the array, checking if the next element is present in the next index or not. If it's present, then we are incrementing the count and then returning it. The solution will work, but will at the end lead to a runtime complexity. So the time complexity for this solution will be O of n log n. That is because we are sorting the array, and the space complexity will be O of 1 as we are not using any extra space here. But the problem clearly states that we have to solve this in an O of n time. So this solution won't be working. So we need to look for a better approach here. So to find the optimal solution, what we can do is to use a data structure known as set. So the set will be storing all the elements of the array. We know that set stores unique element and we can do a constant time lookup. So set is a very prominent solution here. So we'll add all the values of the array into the set first. Now we will traverse through the array, and what we will do is, so when we are at the first index, we will check if the previous element to this exists or not. So we are doing this to basically find the starting of the consecutive sequence. So the value is 100 here. So 100 minus 1 is 99. So if 99 is not present inside the set, then we know that 100 is the starting point for this consecutive sequence. So 100 minus 1 is 99. 99 is not present, so 100 is a start to a sequence. Now that we have found the start, we need to check the sequence. So after 100 there comes 101. So we will check in the set is 101 present. So 101 is not present, so this is the end of the sequence. So we will keep a variable length to track the maximum length of the consecutive sequence. So until now what we have found is 100 is the only sequence, so the maximum length is going to be 1. So now after 100 we go to 4, we check 4 minus 3 if it is present or not. So we will check 4 minus 1, 3 is present or not. So 3 is present inside the set. That means 4 is not a start to any sequence. So we move further up to 200. We see 200 minus 1 is 199. 199 is also not present. So 200 could be a start to a sequence. So after 200, we will be checking 201 inside the set if it's present or not. If it's not present, then we can say that this is the end of the sequence, and so we can check if the length of this sequence is greater than the current length or not. Here it's equal, so we don't need to change anything. Now when we come to 1, we check if previous element to 1 is present in the set or not. So 1 minus 1 is 0. So 0 is not present inside the set. So we can say that 1 is a start to a sequence. Now that we have found the start, we'll look to the next element if it's present. So the next element to 1 is 2. So we check 2 is present in the set. So we can add it to the sequence. Then after 2, we can check for 3. 3 is also present in the sequence. After that 4 is also present in the set. So we can add it to the sequence. After 4, 5 is not present in the set. So this is the end of the sequence. So we can pick the length of this sequence, that is 4, and check if it's greater than the current maximum length or not. So here the current maximum length is 1 and 4 is greater than it. So we can update the maximum length to be 4. So after that we move to 3. So we check the previous element 2. 3 minus 1, 2. 2 is already present in the set. So we move further for 2. 1. So 2 minus 1 is 1. 1 is already present in the set. So we move to the next element, and we know that this is the end of the array. So our maximum length is 4. So the time complexity for this solution will be O of n, and the space will be O of 1. So we got the required time complexity and at a constant space. Okay, so we'll first take a variable to store the longest and initialize it with 0. Then we will take an unordered set of type int. Then what we will do is we will put every element of the nums array into the set. We can insert it, st.insert nums of I. Okay, then we will be traversing into the set now, and we will be checking if this is the start of the sequence. So we will check it by looking for the previous element if it exists or not. So if it is the start of the sequence, then we will initialize a count variable from 1, and then we will check until where we are able to find the next element, and then we can increment the count variable. And then we can check that the longest is equal to the maximum of longest and the current count, and then we can return the longest.